All right, this video is for the review for day 11. I was asked to do 1A, 1C, and 2A. I'll also be doing day 12, 7, and 48. Those were the only problems that I was asked to do. Okay, so the first one is the sine of 15. The sine of 15 can be rewritten as the sine of 30 divided by 2. So we're dealing now with a half angle identity. And since the angle 30 is in quadrant 1, we're going to be using the positive one. And the half angle identity for the sine is plus or minus the square root of 1 minus the cosine of 30 divided by 2. That's all underneath the radical. So since it's a plus, we're just going to leave it as positive 1 minus the cosine of 30. Well, the cosine of 30 is going to be root 3 over 2, and that's going to be divided by 2. Adding the numerator, I need to make a common denominator. So we get the square root of 2 minus root 3 all over 2. And that whole thing is divided by this 2. So I'm going to multiply by 1/2. So it gives me the square root of 2 minus root 3 divided by 4, and the denominator I take the square root of, and it becomes the square root of 2 minus root 3 all over 2. All right, 1C, I'm going to do exactly the same, except here we're dealing with radian measures. The cosine of pi over 12 can be rewritten as the cosine of pi over 6 divided by 2, because pi over 6 divided by 2 is pi over 12. Pi over 6 is also in the first quadrant, so it's going to be positive. And that is going to be plus or minus the square root of 1 plus the cosine of pi over 6 divided by 2. So doing it the same way, it's just going to be plus. We'll make that 2 over 2 plus root 3 over 2, all divided by 2. Square root of 2 plus root 3 divided by 2, and that's all divided by 2, or times 1/2. So we're going to end up with the square root of 2 plus square root of 3 all over square root of 4, or 2. The 2a is the cosine of negative 3/7. That's given to us, and we're told that the angle's in the second quadrant. So we're going to go ahead and put that angle over here in the second quadrant. The cosine is the adjacent, so that's a negative 3 for the x. Hypotenuse is always positive. By Pythagorean theorem, you can find this to be 2 root 10, and it is positive. If it was down in the third quadrant, then we'd, of course, make it negative. All right, so we're asked to find the tangent of this. The tangent of 2x. The identity for the tangent of 2x is going to be 2 times the tangent of x divided by 1 plus the tangent squared of x. All right. So the tangent of x is going to be the opposite over the adjacent. So it's going to be a negative 2 root 10 all over negative 3. Never mind, that is a negative fraction, not negative over a negative. So that's just going to be a positive 3 down here. And that's going to be divided by 1 plus the tangent squared. I have the wrong identity here, guys. That's a minus. That's a minus. Okay, so I fixed that up. It's a minus here and a minus here. So it's going to be 1 minus that same fraction of 2 root 10 over 3, and of course it's negative. Okay, so up top we're going to multiply those together. That's going to be a negative 4 root 10 over 3, and that's divided by, we're going to make this, that's squared. We're going to make this 9 over 9 plus, because it's a negative and negative, no, minus. So it's minus because we are squaring this negative 2 root 10 over 3, which becomes 4 times 10 or 40 over 9. Let's see if I can come up here, I had a little more room. So that's going to be negative 4 root 10 over 3 divided by 9 minus 40, or negative 31 divided by 9. All right? So I'm just going to multiply by the reciprocal, and it's a negative 4 root 10 over 3 times a negative 9 over 31. Well, the negatives will become positive. This 3 cancels into the 9 3 times, so it looks like we have 12 root 10 all over 31. Okay, the next two problems are from day 12. I'm going to do number 7 first and then 48. In 7, we're given that the sine of theta is equal to 15 over 17, and the fact that the angle is in quadrant 2. So if my angle's in quadrant 2, it'll be drawn in over here. The sine is going to be the opposite over the hypotenuse, so this is 15 over here, 17 here, and by Pythagorean theorem, we're going to find this to be 8. However, you need to make it negative 8 because we're in the second quadrant. Now, the sine of 2 theta, anything in the second quadrant multiplied by 2 is going to end up down here in the third quadrant. So in the third quadrant, cosine is negative, sine will be negative, and of course that's going to require or end up then with a tangent being positive. All right, the sine of 2 theta is equal to 2 times the sine of theta times the cosine of theta. So that's going to be 2 times 15 over 17 times a negative 8 over 17, and nothing's going to cancel out here, so that should be negative 240 over 289, and it is negative, exactly what we expected. The cosine of 2 theta, we have 3 choices. It doesn't matter which one you pick. I think this is the center one. 1 minus 2 times the sine squared of theta. All right, so it's going to be 1 minus 2 times the sine squared. Well, the sine is 15 over 17, and I'm going to square that. So the denominator is going to be 289, so I'm going to put a 289 over 289 for the 1. Minus now 15 squared is going to be 225. 225 times 2 is going to give me 450. That's a 450. Not real clear. All right. And that 450 is going to be over 289. So all we got to do is take 289 minus 450. We're going to get a negative 161 over 289. And again, we did expect it to be negative. The tangent of 2 theta is 2 times the tangent of theta over 1 minus the tangent squared of theta. All right, 2 times the tangent of theta. The tangent of theta is the opposite of adjacent, so we're going to go with negative 15 over 8 all over 1 plus the tangent squared. So it's going to be negative 15 over, did I say plus there? All right. That's a minus. 1 minus negative 15 over 8 squared, so it's going to be positive 225 over 64. All right, multiplying this together, the 2 and the 8 cancel out, so it's going to be negative 15 over 64 divided by, and I'm going to make this 64 over 64. So 64 minus 225 is also negative 161 over 64. So I'm going to bring that up and multiply by the reciprocal, negative 64 over 161. 64s cancel out. Negative times a negative is going to be a positive. So that looks to be, there's an error right in here somewhere. The 2 and the 8, I put a 64 here. That is not a 64. Right? The 8 and the 2 cancel out. That's just a 4 here. So if I make that a 4, the 4 cancels now 64 16 times. And 16 times 15 is going to be 240 all over 161. And it turns out to be positive, exactly what we expected it to be. All right, sorry for that confusion. 48, we were going to be looking for the cosine of theta divided by 2, so we're looking for a half angle. We're given this triangle, 3, 4, 5, and mark theta here. They didn't say anything about what quadrant it's in, but without being told anything, it's not in standard position. So we're going to assume that theta is between 0 and 90. It's an acute angle. So the cosine of theta is going to be plus or minus the square root of 1 plus the cosine of theta divided by 2. Well, since we're assuming this thing's an acute angle, it's going to be positive 1 plus the cosine. The cosine is the adjacent over the hypotenuse, or 4/5. And that's all divided by 2. So the 1 we're going to turn into 4 over 4. So that's going to be the square root of 8/5 divided by 2, or times a half. So that becomes the square root of 4 over, looks like square root of 5. Except that's not 4 over 4, that's 5 over 5. My denominator is 5, not 4. So this is all messed up. Well, you guys are going to hate this. Let's just erase this step. Make it a little bigger here. And do that one again, because I've got the square root of 5 over 5 plus 4 over 5, or 9 over 5 divided by 2, or times a half. All right, that looks a little bit better. So that's going to be the square root of 9, or 3 over square root of 10. And of course, now we need to rationalize that, root 10 over root 10. So our final answer should be 3 square root of 10 all over 10. My apologies for that mess up. Hope that helps. If you have any further questions, please don't hesitate. I'll make another video later today. But get prepared for that quiz. Thank you.